Hey folks, Mr. Lee here. Alright, this practice is on evaluating functions, specifically in function notation. Okay, so just a little review of function notation. We read this as f of x, right? A function in terms of x will be equal to whatever is on the side, right? In this case, 14 minus 0.5 times x. Okay, so f of x is also an output value. Everything I've highlighted right here, this will be your final y value. All right, you could just say this is y is equal to 14 minus 0.5 times x. Okay, you could do that if you wanted to. Only the x like that is your input x value, but then when I highlight the whole thing, that's your y value. So basically it's asking what's the y value when you have a specific x value. Okay, so then we see this, f of 30. Okay, you're not going to do multiply by 30. It's not f times 30, even though it looks the same. F of 30 means what's the y value when your x value is 30. Okay, so I'm going to use the calculator, but then I'll break it down a little bit further. So I want the y value when my x value is 30. Okay, so let me I'll replace this y. No, I'll leave it like this. So f of 30, okay, is going to be equal to 14 minus 0.5 times x. Okay, so notice how I left the empty parentheses here. I'm going to replace it with whatever the x value is. So in this case, it's f of 30. So it's going to be 14 minus 0.5 times 30. Right? So let's evaluate what it is. Okay, the calculator can do the work for you, right? 14 minus 0.5 times 30. It's a nice negative 1. Okay, if you want to break it down further, right, just do one at a time. Figure out what 0.5 times 30 is. That's like half of 30, which is going to be 15. All right, and then you're doing 14 minus 15, which is still your negative 1. Okay, so this is all the work in one shot if you want your calculator to help you with that. But then you can also break it down, right? Follow order of operations. But negative 1, there we go. Okay, we'll do several more here. So this one we have h of t equals 50 minus t over 5. So we're moving away from just your standard x and y variables. That's also a benefit of using function notation, right? We can now use any quantity, any unit that we want to represent these variables. So in this case we have h and t. Okay, so h of t is essentially your y value, and then t is like your x value, your input. Okay, so it's asking, what's the h value when your t value is 35? Okay, what's the y value when your x value is 35? Okay, so let's follow this. We have h of 35 should be equal to 50 minus, I'll put it in empty parentheses, t over 5. Right, notice how I left that blank. So 50 minus t over 5. My t value is 35, so I'm going to evaluate it at 35. Okay, so the same thing as that, gives me 43. Okay, again, you can break it down if you want. If you just want to figure out what 35 over 5 is, that's going to be 7, right? 35 divided by 5 is 7, and then you take your 50 minus 7, you still get 43. Okay, do a couple more here. So this one I have f of x equals 5x minus 3. I want to figure out f of 5. So it's going to be f times 5 minus 3. Okay, all I did was replace the new input x with 5. New input x with 5. So then it's 25 minus 3. This one I'll break it down, right? 5 times 5 is 25. 25 minus 3 gives you 22. Okay. All right, one more. This one's g of r. I like the samples or the examples with different letters. So I'm trying to find the g value when you have a specific r value. Okay, output g of r, input just r. Okay, so what's our input here? G of 4 should be equal to 25 minus 3 times 4. Okay, so 25 minus 3 times 4. You can break this down if you want. 3 times 4 is 12, so 25 minus 12 will give you 13. Done.